I hope you guys are doing well. I just realized this is going to be the last lecture of the quarter. Um, so I guess this is cause for celebration and it's bittersweet. Hopefully you guys went to this. I forgot I saw something posted on your guys' Nectar about like a review session hosted by one of the CLAS tutors. I believe it was this morning. Um, I hope it was helpful for those that did go, and for those that didn't go, I'm sure that you still have plenty of opportunities to get ready for the coming final that you guys have on Saturday. And so keep in mind that I will still have drop-in hours today and tomorrow. But after that, I believe that that is it. So let's go ahead and get started on today's material. Today is going to be mostly a lot of practice problems. But I do want to kind of reiterate some of the last points that I made on Monday, because I know that it was a little bit rushed as I was kind of closing in on time. But I just want to kind of review that firms produce where price equals marginal cost, right? And if you remember, we have this graph that was kind of like this, where we have our average variable costs and we have our average costs. Whoops, should be right here. And through the minimum points of each of these curves, we have our marginal cost and we have P and Q here on this axis, right? And so this gap right here between average cost and average variable cost is what we call our average fixed cost, right? And so we know that in a market, right, where there's a lot of firms and we assume that there's perfect competition, the price is just given to us, meaning that no matter what our actions are on price, no matter what our actions are, like whether we change our price or not, the price is just going to be given, because if you change your price, people are just going to go to other firms. So you want to charge the price that's the market price, okay? And so we know that price is equal to marginal cost, because if you look at our profit equation, we have P times FLK minus total cost. And so total cost right here is just an aggregation of the cost of labor times labor plus the rental rates times the amount of capital that we have. So I'm just going to leave it as kind of total cost for now. And so remember that all of this FLK, all of this goes into producing a value for quantity, right? And so when I want to determine what the optimal amount of quantity to produce is, right, you would take just the derivative with respect to quantity, right? And this is equal to P, right, because Q is the variable that we're taking the derivative of, and P is just a constant. And this is minus marginal cost, right, because the derivative of total cost with respect to quantity is how much our cost increases when we produce one more unit. And that's the marginal cost of producing one more unit, right? And we basically want to find that point where profit is no longer increasing or decreasing. And so this is why we set it equal to 0, which is where we get P equals marginal cost from, okay? So this is kind of like the origin for our equation. But I think for your guys' sake, it's just important to know that P is equal to MC. And kind of similar to the first order conditions that we worked with on Monday, this is a very important equation that's going to allow you to kind of work backwards on a lot of different problems. So I do want to talk about firm production, both in the short run and in the long run. So in the short run, we assume fixed cost, right? So I'm just going to leave this as like K bar. So actually, no, that's a little bit hard to read under context. So we have fixed cost, which imply we have a K bar, right? And so in the short run, because we have fixed costs, these fixed costs are essentially, and I hate to say the word cost again, but they're costs that we incur no matter how many units we produce, right? And so if you think about how much to produce in the short run, you basically want to produce as long as the cost of producing one additional unit, which is your average variable cost, is less than the price at which you can get that unit for, if that makes sense. So if you think of your variable cost as labor, that's essentially saying that in the short run, I'm going to keep producing as long as the revenue that one more unit of labor brings in is more than the wage at which I would pay that laborer. Okay, that's kind of what it means. And so this is why we have it that we produce when P is greater than your average variable cost, right? And so in this scenario, it's still possible for you to be making a negative profit, right? It's just that you're making more profits than if you just hadn't produced at all, right? Because if you think about it, your profit is equal to P times Q minus total cost, right? And so if we're talking about in the short run, producing 0 units, right, is equal to 0 minus your total cost. And your total cost is just going to be R times K bar, right? So your profits in the short run is equal to negative R K bar, which is the amount you pay for like the lease on a building or something like that, right? Now, if you're able to make more in profits or more in revenue than the cost of your variable labor, so let's look at, for example, let's see, P times Q. So as long as, I'm trying to figure out where to write this. I'm going to erase this. Hopefully you have that written down. And I'm going to say that as long as P times Q is greater than W times L, then in this scenario, you're going to produce in the short run, right? Because essentially what I'm saying, like what this means is that you can make more profits than your negative R times K bar if you keep producing. So hopefully that kind of makes sense to you guys intuitively. You're still going to make negative profit, but you're still going to make negative profit, but you're making less losses than you would if you just hadn't produced at all, which is a little bit hard to kind of think about, but it's essentially a lower value for your negative profits. Okay, so this is basically the assumption is that in the short run, you're going to produce as long as your price is higher than your average variable cost, right? So if price is here, right, you know that you produce where your price is equal to your marginal cost. And this point right here is above your average variable cost. So in the short run, you're going to produce, okay? And so let's erase this. However, if price in the short run is right here, right, you would be better off, not producing at all, because not only are you taking on this loss of your fixed cost, but you're also in a situation where you're making less revenue than the cost of hiring individual labor is, right? So for each unit of labor that you hire, you're actually losing money for that, so you might as well just not hire any labor at all. That's kind of the intuition there, all right? So this is in the short run. In the long run, where we assume no fixed costs, right? We produce when price is greater than your average cost, right? Because in this scenario, you have the option of taking on a new lease, right? But you haven't yet, so you don't have any costs up to this point. So you want to make sure that the price, right? So you basically want to make sure that if you look at this equation, P times Q, right, minus total cost, right? If you divide everything through by Q, you get that P minus average cost And so as long as P is greater than average cost, your profits are going to be positive, right? So I guess your profits divided by quantity, so your average profits, okay? As long as P is greater than your average cost, this value right here is going to be positive, which is obviously a good thing, okay? So for example, if you're in the long run and you have a price that's right here, you're going to produce here, right, where your cost or where the price is equal to your marginal cost, and this is obviously higher than right here, and so you'll produce. In the long run, however, if the price is here, for example, you're not going to produce. And this is like the main distinction between the short run and the long run, is that in the short run, anything above here is something that we would produce. In the long run, anything that's above here is something that we would produce. So essentially, we lose this portion of the graph when we switch to a long run scenario, okay? So this is kind of just a quick introduction to like the cost curves and what they mean. I will kind of, I want to talk about just quick producer surplus, just because it is covered in like topics such as land rents, which I'm going to talk about in just a minute. But essentially, if you think of your profits as being basically the difference between here, right? So your average cost is right here. So kind of to take a step back, the way that we would measure profits is if we were to essentially look at the price at which we can sell our items, right? So let's make it a little bit more clear. So we take a look at the price at which we can produce our goods and sell them for. We know that we're going to basically set our quantity so that it's at this point right here, right? So here's a line that goes straight down, right? And basically the amount of profits that we have is going to be this gap from where our price hits our marginal cost, and we go straight down from there and see where that hits our average cost, and we draw a straight line out to here, and we say that this is going to be our profits, right? And so this is kind of how we measure profits. And the main distinction between profits and producer surplus is that our producer surplus doesn't take into account fixed costs, meaning that we include it in our producer surplus, right? So let me redraw the graph. Okay, so if this area right here was our profits, this area right here where it touches our average variable cost and we go straight back out to price, this is our producer surplus. And so your producer surplus, I believe, is, if not always, mostly going to be greater than your profits. And there's cases in which I think they're equal. But yeah, that's kind of the implication here. So producer surplus is basically the gap between your marginal cost and your average variable cost times the amount of quantity that you produce. And profits is the gap between your marginal cost and your average cost times the amount that you produce, okay? So yeah, there's that. I also want to briefly talk about like market supply, just as like an aggregation. So in terms of like the entire market and what our supply curves and our cost curves are going to look like. So let's say that this is our marginal cost. We say that we have a price that's right here, right? And our firm is currently producing at this level. However, because of this situation, we see that this firm right here is producing profits. They're essentially doing very well, which is going to influence other companies to enter the market, right? And so when more firms enter the market, you can think of a supply and demand curve, right? So demand, supply. Essentially, if we have more supply, and this is like in the aggregate, right? If we have more supply, this is essentially going to force our price down to the point in which our new price is eventually going to be at the point where it hits our marginal cost right at the intersection of marginal cost and average cost. So this is what we consider an equilibrium price, right? It's going to be at this portion of the curve where we have an intersection between marginal cost and average cost, right? Essentially, prices are going to be forced down to the point in which there's going to be zero economic profit. And so that's kind of like a distinction that's made between like accounting profits and economic profits, is that essentially economic profits is basically, I'm trying to think, when you have zero economic profits, you're still able to maintain your business and kind of keep things going. Whereas when you have zero accounting profits, that's not good. So zero economic profits is kind of normal, whereas zero accounting profits is a bad thing. So just kind of get used to that distinction. But essentially, we're going to be forced down to the point in which the market has zero economic profits, which basically is going to deter people from entering, but it's also going to deter people from leaving the market, right? Which is why we call it an equilibrium. So if it were the opposite case, say that we started off in a situation where the price in the market had been right here. So this was price, right? Firms in this case are making negative economic profits, right? Because we can see that their price at which they're selling the goods for is less than the average cost. And so firms in this market are going to leave, right? And so kind of like the opposite of what happened here, when firms leave, that shifts the supply curve kind of upwards. So it restricts supply, which forces prices up until the point where we have an equilibrium price where the marginal cost again intersects with the average cost curve, right? So essentially, if price starts off above average cost, right, above this point right here, if price starts off above it, firms are going to enter until it forces prices down. But if price starts below this point right here, then firms are going to leave until prices are at an equilibrium, okay? So I think that I've covered mostly what I wanted to talk about with respect to cost curves. And now I do want to get into some practice problems regarding just, I don't even know how to describe them. They're just like, you've seen them in extra problem sets 8 and like 9, some of the later extra problem sets. And you'll notice that there's not a lot of wording that's associated with the questions. And so I'm going to kind of walk you guys through how to best approach these. So this is extra problem set 8. And if you guys want to follow along, you're more than welcome to, or you can kind of walk me or see me walk through the problem and give an explanation as well. So question 1 is we're given long run total cost is equal to WR times Q squared. And we're asked for the long run marginal cost, and we're asked for supply. So long run marginal cost, I believe, should be fairly easy to kind of compute, but supply is a different issue because it's very vague what it even means to supply. Like, what are the parameters of interest? And so, like, how do we know if we found the right answer? Okay. So let's first start off with our long run marginal cost, right? We've already established through the equation that we had for P equals MC. If you remember, the way that we were able to derive this was by saying that the derivative of total cost with respect to quantity was equal to our marginal cost, right? And so if you kind of think through to what we have right here, we have total cost and we're looking for marginal cost, which is why we're going to be able to just set the derivative of this with respect to quantity and get 2WRQ, right? So this is a fairly straightforward example, right? Knowing this identity, right, is again very key to be able to like determine this. Um, and so yeah, this part A should be fairly straightforward. However, when they're asking for supply, it becomes a little bit more ambiguous. Like obviously we're going to be looking for Q, right? Because this is how much we supply. But what is Q, right? Well, this goes back to knowing your identities and knowing how to kind of work through here, right? Whenever you're dealing with these cost questions, I would always go back to this P equals MC equation because this reveals so much information and allows you to kind of take the bridge and introduce new variables into this equation that maybe you haven't really seen before or have not been introduced yet. So let's use this identity. P is equal to MC. This is going to be where we have the optimal amount of Q, right? And so we know what our marginal cost is, right? So P is equal to 2WRQ. And so now we have the parameters that we need in order to solve the problem, right? Where we can get Q in terms of P, W, and R, right? So that we have Q is equal to P over 2WR, right? And so now we have this parameter P, right? Basically, P is a new variable that is very important in determining our supply, right? And now we've introduced it because of this gap, right? This bridge that helped us get there, okay? And so a lot of these problems really won't be given much context behind it. There's not going to be a whole lot of wording. And so it's possible that you might be, so in this case, I think that they only ask for supply, but in other times, another way that this could be written, instead of asking for supply, is simply Q as a function of P, W, and R. And so when you see something like this, it means that they're asking to see the amount of quantity with these variables inside your answer, right? So think of it as like a demand function, if you will, okay? And so that's kind of the thought process that you guys should be having. P equals MC, right, is totally invaluable. Let's move on to question number 2. We're given that Q is equal to L to the 1/2, right? Which you can think of as FLK, right? Because FLK is always equal to Q, right? That's kind of just like an identity that is known. So Q is equal to L to the 1/2, and we're given W equals 4, and we're asked, what is supply? Okay. Does anybody want to walk me through this question, how you guys would answer this? And maybe use this question right here as a template for how to approach this question. If anybody wants to leave this in the chat.
We're gonna just rearrange L and put it in terms of L equals Q squared.
So say that again.
We're gonna pretty much just square Q right here.
Okay, so you say L is equal to Q squared, right? Because this is obviously true, right? And where would you go from
right.
here?
So then I have Q, take the marginal cost, so put it into the W times Q squared and take the derivative of Q from there.
Okay, and why do we do W times T squared or times Q squared? I agree with you. But why is it that this is true?
Because we have to plug it into our cost function.
Exactly, right?
Because we only have Q.
This is equal to our total cost. I think to kind of sum up what Caesar's saying, because we know that Q is only a function of labor, right? We have no necessity for capital, meaning that our total cost, which is typically WL plus RK, right? If K is 0, then RK is 0. And so this becomes our total cost, right? And so now he's basically plugged in Q squared in for L, right? Which allows us to take the derivative of this with respect to quantity, right? And so now we have 2WQ, right? And so this is our marginal cost. And now we're going to set this equal to price and get Q is equal to P over 2W, right? And so now we are, so this is essentially what our demand for Q is, right? And so Q is equal to P over 8, right? Because we know that W is 4. So I give you guys these examples, and for many of you guys, it's probably trivial, but I know that this is something that can maybe be a little bit difficult to kind of understand what they're even asking you because there's so little context behind the question, right? And so it's important to like always try to find a way to get a total cost, because from there you're going to be able to kind of work through the marginal cost equals price identity that we've already established. So that's really good. Yeah, good job. Let's see. I'm trying to think of one more good question that we can work through before I get to the midterms. So this is good for this problem set. If you have any like difficulties with cost curves and cost kind of questions, these extra problem sets I've noticed have a lot of material on these, and so do the later problem sets as well, right? So let's look at problem set 9. Problem set 9, and this will be the last one we get to before we get to one more unconditional labor question, and then we're going to get into the practice final. So this has a lot of wording actually, but we say, suppose that average or short run average cost is equal to, or is a function, I apologize, a function of 200, where 200 is the quantity, W, R, and K bar, right? And this is equal to 16. We're given that short run average variable cost as a function of quantity still being equal to 200 is my W, R, and K bar is equal to 12. And we're also given that the short run average variable cost, right, when quantity is 400, W, R, and K bar are still the same, right, is equal to 16. And so what we're asking is, what is short run fixed cost when Q is equal to 200? All right, does anybody have any ideas about maybe some possible best steps at approaching this question?
We're gonna multiply Q by 16 for the average cost, aren't we?
Okay, so you say multiply Q by 16?
Right.
Okay, to get your total cost, right? And then
Right, that's right. That would be just cost and short run cost at that point, right?
yeah, short run total cost, exactly. And so from there, how would you proceed? So this is equal to 3,200, just by the way.
Yeah, and again, we would just multiply 200 again by 12 to get the average variable cost. And we could subtract from the average cost to get the average, to get the fixed
run cost. Variable cost, which is equal to 2,400, right? And so now we found the gap, right? Short run fixed cost is equal to basically short run total cost minus short run variable cost, right? Which would be equal to 800 in this scenario. And so if you were asked for short run average fixed cost, right, you can see that this gap is still going to be 4, right? So 800 divided by 200 is 4. And so we can kind of just prove that this works, right? So we're given that our short run fixed cost equals to 800. And so now the second part of the question is, what is short run average cost at Q equals 400, all right? So we know what our short run average variable cost is when Q is equal to 400. Now, what is our short run average cost? Okay, and I think that a good strategy for this is, right, just being familiar with the identities that we have, where we have short run average cost is equal to short run average variable cost plus short run average fixed cost, right? So to kind of answer this question, we already have a value for this. This is equal to 16, right? And so now we need to know what short run average cost is and what short run average fixed cost is. Does anybody have any ideas? Any ideas?
Are we going to use the same fixed cost that we just found?
Exactly, right? So this is kind of like the main conceptual part is that because we're in the short run, our fixed costs are what they are, right? We can't change them, we can't adjust them. They are basically going to be 800 no matter how much we produce, right? So our fixed cost when we produce 0 is still 800, and our fixed cost when we produce like 1,000,000 is still 800, okay? So now, if we're finding our average fixed cost, this would be 800 divided by 400 in this scenario, right? Which is going to be equal to 2. And so now our short run average cost is 18, okay? So that's just basically recognizing that our fixed costs are just going to stay the same no matter how much we produce, okay? So this is a good little exercise to be like familiar with the cost. The last problem that I want to get to before I do a practice midterm is from problem set 9, and this is question 4, and it's about unconstrained profit maximization. Okay, so we have f of xy is equal to x to the 1/3, y to the 1/3. Okay, and we have unidentified wage, rental rate, and price. So this is how much we sell the product for. And so what we're being asked is, what is x in the long run as a function of p, w, and r, right? And I kind of talked about this on Monday, except we kind of left with like an unsatisfactory ending. And I think it has something to do with when Cobb Douglases have exponents like 1/2. Like, it just results in like a weird equation in which basically you end up with like y to the 1/2 on the bottom after you do your MRS. And these end up canceling out, and so it's hard to find basically isolate a variable. But that's kind of the only instance in which I think it would be tricky. Other than that, if your variables or if your exponents are not 1/2, it becomes a lot easier to figure out. So let's go through kind of the steps that we took back on Monday in order to solve these questions, right? We determined that step 1 is TRS, step 2 is first order condition, and step 3, plug TRS into first order condition, right? And this is kind of like basically our main 3 steps. After thinking about it, I think steps 1 and 2 are interchangeable. Like, it doesn't really matter in which order you do them. I just kind of like finding the TRS first. That's always like a good first step for me. But it's up to you guys. So if we approach this problem applying these steps, right, we have that our TRS becomes equal to, let's see, 1/3 y over 1/3 x, right? These cancel out, so we get y over x, right? And we know that we can set this equal to our price ratio, or our cost ratio in this case, right? Which is just W over R, right? And we know this because we have diminishing technical rate of substitution, okay? I like to work with basically this top variable that's right here because I can just multiply through by X. And so I get that Y star is going to be equal to W X star R at the profit maximizing level of Y and X, right? Basically, I'm always going to have W over R times X as my value for Y when I'm profit maximizing, okay? So we found our TRS and we found it in terms of the cost ratio. And so now we look at our first order condition, right? We can just use P times MPL equals wage, right? This is something that is hopefully familiar to you guys by now. And so this kind of equates out to P times 1/3 X to the negative 2/3 Y to the 1/3 equals to W, right? After some simplification, this is P times Y to the 1/3 over 3 X to the 2/3, okay? And so we now have our first order condition, and the last step, right, is to plug our value of Y into our first order condition so that we get Y, or P times Wx over R to the 1/3 over 3x to the 2/3 is equal to W. Okay, and now it's just a matter of solving for x, right? I think that and at this point it's basically just algebra. So how I want to solve it is P times W to the 1/3 x to the 1/3 over R to the 1/3 is equal to, is equal to 3 Wx to the 2/3, right? And I'm going to divide by x to the 1/3 on both sides. So this, right, gets canceled out, and this becomes 1/3 as well, because if I divide x to the 2/3 by x to the 1/3, right, I basically just subtract the exponents, and 2/3 minus 1/3 is just 1/3. And so this is kind of how I'm going to isolate x, right? So this can be rewritten as x to the 1/3 is equal to P W to the 1/3 over 3 WR to the 1/3 as well, right? And we can even do some more simplification here, and get W into the denominator. So cancel out this one, right? And this becomes W to the 2/3, right? So let's simplify this out. This becomes P over, let's see, we said 3W to the 2/3, R to the 1/3. And I know that we're running out of space right here, but the last step is basically just to cube both sides. And so what we're going to get from there is, and I'm going to put it right here, X star is going to be equal to P to the 3rd over 27. So 3 to the 3rd is 27. W squared, right? W 2/3 to the 3rds is just W squared. And this is just R. And this is going to be our profit maximizing level of X. And you'll notice that from here, we can plug this back into our TRS and solve for Y as well, okay? So these are the steps in which you would take. Once you get the steps down, I believe that the main thing for you guys is just going to be making sure that you don't make any algebraic mistakes. But otherwise, the steps are pretty organized and there's not too many of them. Are there any questions about this? All right. If there's no questions, I'm going to move on to a few of the good final exam questions that I really liked. and we can go from there, right? So I take it that there's no questions. And so hopefully you guys feel pretty good about all of this. I wanted to throw this in here because we didn't exactly cover a full example on Monday, but I do think that it's important to familiarize yourself with how to solve this. So let's look at final 2018, and this is question 3. And we're given that y is equal to L to the 1/2 K, or L, yeah, whatever. L to the 1/2 K to the 1/2 in the short run, and that F bar is equal to 500, and P is equal to $2, and W is equal to R, which is equal to $1. So the wage and the rental rate are both $1. And what we're asking is, what is producer surplus if she profit maximizes, right? So this is kind of a multi-dimensional question in which we need to be familiar with producer surplus, but we also need to be able to profit maximize before we even get there, okay? So I think that a good first step in this question is acknowledging the fact that, oh, this should be K. Oops. Acknowledging the fact that we have a fixed level of capital, meaning that we can't do any of like the unconstrained profit maximization kind of calculations that we did earlier on. It's going to be a lot more of the constrained, right? Where we already know how much we're producing, which should hopefully make it easier to work with, right? So in order to profit maximize now, we basically need to find a profit maximizing level of L, right? Because since we already know what K is, the best that we can do is to profit maximize L, right? Right, in this situation. So a good first step, right, is because we're not going to find the TRS, we want to use our first order condition. And so P times MPL is equal to W, right? I want to find essentially the profit maximizing level of labor. So this is why I use the MPL, right? So this is P times 1/2 L to the negative 1/2 K bar to the 1/2, right? And so from here, we say that this, right, is equal to 2 to the K bar to the 1/2 over 2 L to the 1/2, right? Because P is equal to 2, so I plug that in. And 2 over here on the denominator comes from this fraction. And so this is all equal to 1, right? So in this case, I have that K bar to the 1/2 is equal to L to the 1/2. And so essentially, whatever K is, that's what L is going to be, okay? And so we know that K bar was equal to 500, which is equal to L. So we now have both our level of labor and our level of capital. And so we can kind of work through here, right? So in this situation, we know that both of our inputs are going to be 500. So how do we find producer surplus from here, right? So producer surplus. Well, producer surplus, remember, is different than profits, right? Profits were price minus average cost times quantity, right? But in this case right here, we can't apply that same equation, right? We need to apply the other equation, right? Which, if you remember, if I just draw my cost curves again, we said that this, right? This right here was profit, but this right here, this whole thing right here, is producer surplus. And this is the point, right, where price is here minus our average variable cost, right, which is here, times quantity, right? So we need to know what quantity is, right? And we need to know what our average variable cost is, right? Because we have the rest. So this is P minus average variable cost times quantity. Well, quantity is a little bit easier to find because we know what our production function is. And so we can just plug in our values for L and K, and that tells us how much we're producing, right? So Q in this case is equal to 500, right? Which is basically just the square root of 500 times the square root of 500, which is just 500. And so now we know what P is. P is just 2. So we have to figure out what our average variable cost is, right? Does anybody know what our average variable cost is? It's given in the problem, but it might not be so obvious. All right, if somebody wants to just leave it in the chat. Right. So our average variable cost, right, in this scenario is the cost of hiring one more unit of labor, right? Because our variable cost is labor, our fixed cost is capital. So our average variable cost is, on average, how much more does it cost to hire one more unit of labor? And we know that our wage is $1. So that's how much it costs to get 1 unit of labor, which is exactly what we're looking for, our average variable cost. And so our average variable cost becomes 1. And so we get 2 minus 1 is 1 times 500. And so our producer surplus is 500, okay? And you'll notice that if you were being asked for what the profit was, that our profit would be equal to 0. So that's kind of just to say that our producer surplus is basically always going to be greater than our profit, right? So I think that this is a good problem.
Can you, yeah, so right here, producer surplus, I do understand where you got the price minus the average variable cost, but the 500, isn't that supposed to be the optimal quantity of production to maximize profit?
Yeah, exactly. So we got 500 because we know that both of our inputs are 500. And so if you plug 500 and 500 here, you're going to get y is equal to 500 as well.
All right, because they're half of 500.
Exactly.
But the square root of 500, you multiply that. Oh, and that's the square root. Okay, gotcha.
Yeah. All right. So I think we have enough time for one more question. This is probably the hardest question that was on this final. And it's a little bit tricky, and it involves kind of some working around of things. So let's just get right into it. And this was question 9. So we're given information, right, to start off with. We have process 1, right? And the goal is to produce acorns, or acorn paste, I think, where process 1, we take the amount of acorns that we get, and our production function as with inputs acorns is equal to A over 10, right? So meaning that we need 10 acorns to produce 1 acorn paste, okay? And we have process 2, where our production function with acorns as our inputs is equal to the square root of acorns, meaning that for every 1 acorn, we get the square root of that back, okay? And so we have that cost of acorns is equal to 1 cent. And we need to find the cheapest way of producing 60 acorns. Okay, so we need to use a combination of process 1 and process 2, in order to produce 60 acorns. All right. So how do we go about this? And this is kind of complicated because I don't think many of you guys have seen a question like this. But just gauging from like the difficulty of your guys' midterms, a lot of the questions that you guys have been getting are just like these weird kind of one-offs. So here's an example of a weird one-off question that's on this final, right? So we need to, as I mentioned before, use a combination of these to produce 60 acorns, okay? So how do we determine how much of each process that we're going to use, right? Any ideas?
We're gonna take half of each then, right? Because if I remember correctly, in one of the lectures it said that if we have two processes equals 100 units, then half of one unit from one process and half of the other unit from the other process, we can use that to.
Okay, so you're saying that we
right?
produce 30 using each process? Is that what you're suggesting? 60 acorns using each process?
That sounds like no.
So
I'm not sure.
it may have been applicable to that question that you used in your lecture, but this one's a little bit different, right? And I'm going to give you guys a hint in that you're going to want to use marginal costs, right? So think about how we can apply marginal cost to this problem right here.
We need to find the quantity though, right? The optimum quantity for marginal before we can apply marginal cost. So then
exactly.
Would we, so if it's 1 cent, then we set A over 10 equal to Q.
Okay.
Right.
So this would be the cost of one of your processes, right? So I'm going to give you guys another hint. Compare the marginal costs for both processes, right? Because we're going to want to use one process over the other when the marginal cost is less than the marginal cost of this one. But then it's not always true that marginal costs are constant. So it's possible that we might use one process up until we produce a certain amount of goods and then start using the other process, right? So let me give you guys a hint. The marginal cost, or I guess the cost of acorn paste for process 1 is equal to 10 times quantity, right? So let's say that acorn paste is Q, right? We say that for, or here, let me take that back. This is 10A, meaning that it takes us 10 units or 10 cents to produce one acorn paste, right? So, whatever, fuck. Let's just use this notation. 10 little a, right? Acorn paste is little a, meaning that in order to produce 10, or in order to produce one acorn paste, it costs us 10 cents. All right, I'm seeing a lot of good answers where you're kind of you're splitting it between the two, but we have to come up to a very exact science when we get through this, right? And so process 2 is a little bit different, right? Because process 1 is very constant in that it's always going to cost 10 cents to produce one acorn paste, right? But it's a little bit different with process 2 because we have this non-linear function, right? So I think that the best way of setting it up is cost of 1 paste, cost of 2 paste, and cost of 3 paste, because we want to see how the cost changes so that we can come up with a total cost function, right? Which we can then use to come up with a marginal cost function. So the cost of one paste, right, is 1, because in order to produce 1 unit, so substitute 1 for f of a, right, we only need 1 acorn, which costs us 1 cent, right? So that's 1. But in order to get 2 pastes, we set f of a equal to 2, and so now we would need 4 acorns, which costs us 4 cents, right? And the same holds true for 3, where basically it's going to cost us 9, right, for 9 cents for three pastes, okay? And so you guys can kind of see the trend that's going on here, where essentially, if we want to find however much the cost is, right, we know that f of a is equal to the square root of a, but a equals cost because each acorn only costs 1 cent. So however many acorns we have is however much our cost is, right? So we know that this f of a is equal to acorns, right? And so if I want to find the cost as a function of our paste, we would say that this a squared is equal to a, right? Meaning that our total cost is equal to the amount of acorns paste that we produce squared. You guys kind of see that little workaround that we just did right here? Does that kind of make sense to you guys? Like why I would want to see the direction in which my costs are like changing?
So I just said a, the square root of a equal to q, because that's like our quantity. Right?
Mm-hmm.
And then I got the same thing, right? But then I took the marginal cost of that, and that would be 0.02
Exactly.
cents.
So this is our total cost, right? This is our total cost, right, as a function of a. And so now we want to find our marginal cost, right? Because that's what's going to determine whether we use process 1 over process 2. So process 1, we have a total cost is equal to 10 times a, right? Meaning that for every acorn paste that we have, it's going to cost us 10 cents. And for process 2, we have total cost is equal to a squared, right? And so if we were to find our marginal cost, this is going to be constant at 10, right? Because you just take the derivative with respect to a. But if you take the total cost of process 2 and you find the marginal cost, this is equal to 2a. So, right, you kind of think, well, at what point is one of these cheaper than the other, right? Well, our marginal cost for process 2 is only 1 for the first acorn paste, and it's 4 for 2 acorn pastes. And we can kind of use the same reasoning to say that when we get to the 5th acorn paste, then our marginal cost is 10, right? But when we get to the 6th acorn paste, our marginal cost becomes 12. And so we would rather use process 1 at that point because the marginal cost is only 10, right? Meaning it's now become cheaper to use process 1 after we produce the 5th unit for process 2. And this is kind of wordy, and so I understand if it's like kind of going over some of your guys' heads, but does it kind of make a little bit of sense how I'm describing it? In that basically 10 equals to 2a, and so a is equal to 5, right? And so essentially process 2 is going to produce 5 units, and process 1 is going to produce 55 units in order to get to our 60 unit total, right? And this is purely because it would cost more to produce all those extra units with this total cost function right here. Are there any questions about this? I know that I went over time, and I know that this is our last time meeting officially. So that's kind of why I went a little bit over. I hope you guys are okay with that. You guys are also more than welcome to go. Um, Before you do, I just want to like wish you guys the best of luck on your final, um, and just kind of acknowledge that it was a pleasure to teach you guys this quarter. I know that it's different when it's remote and we don't have like the same interaction. I don't know what all of you guys even look like, except for maybe a handful. Um, but yeah, uh, feel free to ask questions about this. Uh, like if you want me to walk through it, I'm more than happy to do so. I would probably do it in my drop-in hours, just because it's already 2. Um, but yeah, best of luck, guys. Have fun studying. I know that it's probably stressful for a lot of you, uh, but just know that you can only do as much as you prepare. So I don't know, as long as you guys prepare enough, I wouldn't be too concerned about the results. So yeah, I'm going to leave it at that because it's already 2:01. So it was a pleasure, as I mentioned before. I might still see you guys during my drop-in hours, but if not, best of luck going forward.